Today we're going to learn 13.1, the second day, which is to continue graphing the equations in the form of an exponential growth function from the mother function, which is f of x equals b to the x. So let's take a look at the review on the previous day's lesson to see how some of the important points here are. First of all, we know that the reference points that we're going to be using to graph are 0, 1, and 1b. B stands for the base of the function. And then we're going to use these formulas here to obtain our transformation equation. But I think it's much easier if we just use the example to describe it. So let's take a look at an actual example of how to graph. So here's the equation. And as you recall, all of the characteristics from the transformations in the previously studied functions like cube function, square root, anything like that, they are transferred directly over to this concept. So it's the same idea. Like for example, a negative in front means that this is going to have a reflection across the x-axis, just like before. And then 3/5 in front is a vertical compression because it's less than 1 of a factor of 3/5. And then next we can take a look at the number that is next to x. So the number that is next to x is h. That is going to tell us that we're going to be moving left or right. In this case, because it's x plus 2, we're going to be moving 2 to the left, and then finally plus 3 in the back means we're going to move 3 up. So that's basically all of the transformations. We're going to be using that to help us when we get to the reference points. So let's keep that in mind. So that's the first thing, naming all the transformations. Let's start with step A. The domain for any exponential function, exponential growth or decay, has a domain of Oreos. So that's just the first thing. Or you can just write it as negative infinity to infinity. That's just another way to write it. The range, in this case, for the range, we actually take a look at two things. One is we understand that a normal exponential growth function actually should take the shape of something like that curve right there. But because of that negative, there's a reflection across the x-axis, which means this graph is all of a sudden going to be opening down, turning down like this. And then on top of that, it has been shifted 3 units up. So originally the horizontal asymptote is at x equal to 0, but now it's going to be shifted up to 3. In fact, we can actually go ahead and graph the horizontal asymptote because we learned in the previous lesson that we have the horizontal asymptote defined by k right here. K equals 3 in this case. So k equals 3. So we have the equation y equals 3 is the horizontal asymptote, HA. And that affects our range. So the entire graph is going to be below this line right here that is defined by the horizontal asymptote. So that's why the range is going to be y less than 3, because the graph should lie below that line. Because as you can see, it's going below because it is reflected across the x-axis. So that's A and B. Part C is when we're going to actually, and the asymptote, we can actually do that. So the horizontal asymptote, once again, is defined by y equals k, which is 3 in this case. And so now we're going to go ahead and prepare the table. And the table involves the x and y transformation. So the transformation that affects the x is that we're going to go 2 to the left. So going to the left, we subtract. Going to the right, we add, which means going to the left, we're going to subtract 2. So x minus 2. And for the y, we're going to take the negative and then also the 3/5 in the front, multiplied by the y. So basically pretending this whole thing is y. And then we're going to add 3. So this will have some kind of a fraction to it, but it's okay. And let's go ahead and list the two reference points. Remember, the reference points are 0, 1 and 1 b. The base is actually 10 for this problem. So we're going to write 10, 1 comma 10. That's the second reference point. And we're going to take the x value and subtract 2. So taking x minus 2, so that's going to be 0 minus 2, which is negative 2, 1 minus 2, which is negative 1. The y is the second number here, so we're going to just do the math. Negative 3/5 times 1 plus 3, that will give me 2 and 2/5. So you can use a calculator to help you out if you need to. The second point is negative 3/5 times 10 plus 3, and we can do the math. 5 goes into 10 twice. Negative 6 plus 3, that gives me negative 3. So my 2 points, new points after transformation is negative 2, 2 and 2/5. And the second point is negative 1, negative 3. So I'm going to graph that on my graph here. So negative 2, 2 and 2/5 is like sitting right there, a little bit underneath that line. And my pen is kind of thick, so I can't get close here. The second point is negative 1, negative 3, which is right there. So my graph, I already know it's going to look like a curve facing down like this. So it kind of looks like that. So this is approximately what the graph should look like. For a more accurate graph, you can go ahead and enter this graph directly into decimal, the original equation, and you should see exactly what the graph looks like. So you can use that to verify. And basically, that is how you manually go through and graph one problem. So let me have you guys try this problem here, the same exact way that we just did, and see if you're getting this. So go ahead and pause the video and try it. Hopefully you've had a chance to try it. So let's start with the transformation. So we do have 1/2 in the front, which will be resulting in a vertical compression of 1/2 because it's less than 1 again. 2, it's a plus 2 again, so we're going to go 2 units to the left, and then a minus 4 means it's going to be 4 units down. So there's 3 transformations here. The domain, once again, is Oreos. And the range, since this one does not have a negative in front, so it will just go with the normal curve of an exponential growth function, which looks something like that. So it means that it should be y greater than, because it's going above, right? That horizontal asymptote right there. So it should be y greater than negative 4 for the range. Again, the horizontal asymptote is defined by the number at the end, which is k. So that would be y equals negative 4. And it is a line horizontal along the number 4. So here it is, the horizontal asymptote, HA. I'm going to label that. And finally, we are going to use the reference points again. So the reference point is 1, it was 0, 1, and then 1, comma 2. So 1, 2 is the second point. And based on our transformation, our x transformation moving 2 to the left will be x minus 2 again. And then y is going to be 1/2 y, and then minus 4 in the back. We're going to go ahead and do the math. So taking the x minus 2, that will be negative 2. 1 minus 2, again, is negative 1. Doing the math for the y, it's 1/2 times y minus 4. That'll give me negative 3.5. And then for the second value, it's 1/2 of 2 minus 4, which is going to be 1 minus 4. That's negative 3. So I'm going to try to graph that over here. Negative 2, negative 3.5. Negative 2, negative 3.5 is right there. Negative 1 and negative 3 is right there. So I'm going to draw the curve as much close to these 2 points as I can. And there is what the graph should look like. And once again, you can use decimal to enter this original equation into decimal and see if it looks like that. It should look like that. Okay, so that's the end of that problem. Next, we're going to move on to the next concept here, which is to, given the equation, the graph of a function, you are to write the equation. So we're going to take a look at how to do that. So there are some things that are given. So for example, they give you the base of the function, which is 10 in this case. And then they give you 2 points here with the values already given. So since we know the general equation is y equals a times b to the x minus h plus k, we can identify some points here. The first thing that we know is, remember, y equals 6, which is the horizontal asymptote right here. And that is actually equivalent to k. So we already know that k equals 6. The next thing we know is the point that is closest to the horizontal asymptote is going to produce h. The first number is actually going to be h. So we're going to use that point for h right here. So that's going to be h. And then also, the other point that is given that we have not used, we're going to label it xy. So we're going to use any point, call it xy, to complete our equation. So now we're going to evaluate and substitute the numbers that we know. So y is equal to negative 10. A, we do not know. That's what we need to find out. So we're going to leave it a. The base, they're telling us that it's 10. So we're going to use the 10 that is given. X is negative 3. It's right here. And then minus h. Well, that's a minus 4, which is a plus 4. And then finally, we have k, which is 6. So that's a plus 6 at the end. And we're going to simplify this problem. So first thing that I should do is get rid of that 6 in the back. So I have negative 16 is equal to a times, right here simplifying, we have 10 to the first power, which is just a times 10. Or we can divide it by 10 now. To get rid of that, we have a is negative 16 over 10, or reduce that to 8 over 5, and it's negative. So we have a equals negative 8 over 5, or I'm just going to change that to negative 1.6. So I'm ready to write my equation now. So y should equal to negative 1.6 or negative 8 over 5, whichever you prefer, times 10 to the x plus 4 plus 6. And we have a horizontal asymptote at y equals 6. The domain should be all reals again. And the range, it says to state the domain and the range at the end. So the range should be y. The graph goes below the horizontal asymptote of 6, so it should be y less than 6. So there is the entire solution for this problem. And that's the end of the problem. So let's go ahead and have you try this problem right here. Even though it does not say, I think it was cut off, the try. So you guys can go ahead and try this problem, pause the video before you look at the answer. Well, hopefully you've had a chance to try the problem. First thing is that we know the base is equal to 2, and also we notice that this is the horizontal asymptote right here, which is y equals negative 5 over 2, and we know that that is k. So given the equation, once again, y equals a times b to the x minus h plus k. We already know that k is negative 5 over 2, so we're going to substitute that. And we're going to use the point, once again, closest to the horizontal line, and use that number in the beginning for h. So we know that h is 3. And the other point, we're going to use it as xy. So y is equal to 1/2. A, we do not know. That's what we're trying to find out. B, we are given. B, the base is 2. X, that's 4. So it's 4 minus h is 3. Okay, and so now we got everything set. We're going to get rid of the 5/2 first. So adding 5 over 2 to both sides. And we have 1/2 plus 5/2, that's 6 over 2, which is 3, equals a times 4. 4 minus 3 is 1, so that's just 2. And then we're going to divide it by 2. So the answer is a equals 3 over 2, or 1.5, whichever you prefer. So y is equal to 3 over 2, or 1.5, 2 to the x minus 3 minus 5 over 2 is the entire equation. And the horizontal asymptote is at y equals negative 5 over 2. We have a domain, which is all reals, and we have the range is y. The line, the graph goes above the horizontal asymptote, which is y greater than negative 5 over 2. And that is the entire problem. So that's the end of the problem. Here's a discussion question. Describe the steps that you would take to graph the function which is given right here. And I'm going to take that out so we can see the equation. And so here's the graph, the equation, and then describe and explain the transformations from the parent function. So first we can use the transformation and the reference points, right? The reference points, remember, are 0, 1, and 1 comma b. In this case is 1, 2. So that would be the base. And then use the transformation. So it looks like for the transformation here, it's going to be 1 unit to the left and 1 unit down. So from here on, you can, use this table that we just created with the reference points and obtain the general equations, which is going to be x minus 1 and then y minus 1, and obtain your new reference points and then graph it. So those would be the steps. And the transformations from the parent function, we already did it right here. So transformation is 1 left and 1 down. So those are the transformations, and follow those steps. You should be able to obtain the new graph. And that's the end of the discussion question and also the end of the lesson. So you can go ahead and get started with your assignment. Refer to Google Classroom for your assignments. And have a nice day. See you next time.